Okay, the third example then for this particular lesson, we're looking at determining the length of the support wires connecting the given tower. So the support wires are our lengths X and Y. So those are the ones we are looking at. We want to find how long do those cables need to be in order to support this tower. So what information is given? We know that the connection distance between wire 1 and wire 2 is 18 meters. And we know the angles inside the two triangles respectively. So for this particular question, I'm just going to redraw it without the fancy detail here. This is basically what we know. We know this is 18. We know this angle is 20 degrees. We want to know X. We want to know Y. And we know this exterior angle is 50. So we can find the interior angle because we know a line makes a 180. All right. So therefore, if I call this theta, theta will equal, I know it's 180 degrees on a full line. I'm going to take away 50 of it. So that is 130 degree angle in that theta. So now I have two angles. Well, now that I have two angles, I've got a third angle. So the third angle, I'll just call it another Greek letter here. Let's go with phi. So phi looks a lot like theta. 180 degrees in a triangle, 20 degrees at the top, 130 on the one corner. So that means that angle there will have a sum of 150, so it's going to be 30 degrees. So there we go. So now we know all three angles inside. Now when we look at it, it turns out if you know all three angles, it's not a right angle. It's probably going to be a sine law. So for X and Y, we're going to use sine law again. So very similar to that first page. Whole point here is to realize that that external 50 degrees gives you a lot more information than you first thought. So looking at my diagram, my new diagram, I'm just going to pick A, B, and C. And we're going to go from there. So sine A over A equals sine B over B equals sine C over C. So sine of 30 over 18. So that's going to be the reference or the pivot fraction. We know all the information in that one. B is 20 degrees, and it's our Y value. Sine of C was 130. Sorry, just trying to find where it is on the board there, and X. This allows us to break into two fractions, and in each case, we are using our pivot value. So sine 30 over 18 equals sine 20 over y. So that's the 1. Sine 30 over 18 equals sine 130 over x. Both fractions, the unknown's on the bottom, so I am going to flip the fraction on both sides. Got to make sure you do it on both sides. That's going to allow me to solve. I'm going to multiply both sides by sine 20. So this is looking pretty much the exact same as the previous example at this point. So just using your calculator, we know the cable Y then. So 20 sine times 18 divided by 30 sine, 12.3 meters. Okay. So that's the length of Y. Now my X I can anticipate to be a lot longer. So if this is 12.3, this length over here should be a lot longer. So it's a bit of an intermediate check, I guess, for me. X over sine of 130. Multiply both sides by sine of 130. 130. So now I'm left with X equals, X equals 130 sine times 18 divided by 30 sine. So 27.6, and that seems fairly reasonable. Based on the diagram. So therefore, the cables will be 12.3 meters and 27.6 meters each. So there you go. All right, so yeah, that's still considered a multi-step question. Hopefully some people here are saying, well, that's not bad. I don't consider that multi-step, but that's what we're really looking at today. All right, last example. So usually what people do to measure the width of a lake or a lagoon, rather than taking a boat and going across, especially if it's a lagoon, it's not our preferred choice, but it wants to know the width of the lake. So we're looking for this. Now, surveyor will set up a stake at location A, I'll call it. They'll take the wheel and go toward location B. They will then head to location C, and what they do is they step off those distances, and then using transit, they can measure the angle, and that's how they get the 80 degrees. So it's not uncommon. It's a common surveyor technique for finding the width of something that you don't want to go swimming or diving through. So we know the information given. We know side, angle, side. So we don't have enough information for sine law. So in this case, it is cosine law. So x, and we're going to be using the cosine law. All right. So cosine law says that, doesn't really matter. In this case, I guess I better be in the right order. B squared equals a squared plus c squared minus 2ac. Oh, better not use sine for cosine law. Cos of angle B. Now we just substitute our information. So x squared equals 405 squared plus 325 squared minus 2. 405, 325. That would be cos of 80 degrees. So x squared equals, we can do this in stages. Remember, each of these is an individual calculation. So if you're entering it all in the calculator at once, make sure it's entered appropriately. So 405 squared plus 325 squared. So those two together give me 269,650. So just a intermediate check for you. Make sure you're entering it right, or if you're having problems, you find your mistake. 80 cos, and I get roughly 45712.9. That's negative. So x squared equals 2239371. Don't forget, last step, this is what a lot of people forget, is that square root. So that means that the width of this particular lake is 473.2 meters. The lake width is approximately 473.2 meters. Okay. There's the homework. You're working through there, so you want to pick a selection of questions out of that, and that gives you a general feel for the type of questions I'm going to choose and put on the test. If you have any questions, again, please make sure you mark down where they were so you can remember to ask me in class. See you then.